Hello everybody and welcome to my YouTube channel. I'm Michael and this is the second of two videos about building a fixture for an TTS ER22 holder. TTS stands for Tormach tool system, and the first video covered the concept, the design and the fusion model for this little project. This video is entirely about machining the fixture. Before I start, I want to point out a few details. You might notice the enclosure, the stand for the mill, and the tool rack. All those are homemade. If you're interested, check out my video about installation and setup of the Tormach. And then also I want to point out this little pocket are milled into my vise. More about that at the end of the video. Alright, so let's get started.
Okay, the first step is to indicate the left corner of the fixed jaw. I can use that as a work origin for all setups. Then we place the stock and the vise with two parallels. And align it with the back corner of the fixed jaw. Now we indicate the top of the stock. And now we indicated this corner of the stock. First operation is to face off the stock with a face mill. I use the fly cutter, or Tormach calls it the Superfly. And here we go. The next operation is with a 3/8 of an inch end mill. That is milling the outside contour with a 2D adaptive strategy. These are the two holes for the press fits. Again, 2D adaptive. And we add some air. That is now a 2D contour for both the outside and the two holes to give it a nicer surface finish. And I'll leave 5,000 stock for the following operation. That's dialing in the diameter for the two holes. Next operation is chamfering. And finally, the last operation for the first setup is engraving. And that's it for the first setup. The next operation is dialing in the diameters for the two press fits with the cutter compensation process. The first cut I take is with plus 5 thousandths, just as a sanity check. Okay, now we're going to take some measurements. Okay, after taking the measurement, I reduce the offset to plus 2000 and we run the same cycle again. It's a very light cut. And that's how I dial in the exact diameter. Just take light cuts, adjust the cutter compensation, take a measurement, and go until I have the final dimension. The beauty is that I can do that at the machine without changing the fusion model. It's much faster. For the final check, I prepared a gauge pin on my lathe with 1000 under, and that should barely fit in now. And that's exactly where we want it. And you hear the plop, that's exactly where we want it. So first step before we flip the part over is to indicate Z. Z is going to be the bottom of the part, the machine side. We don't need to indicate the X and Y because we keep it at the left corner of the fixed jaw. Here we go. Now we flip the part over and align this machine side with the fixed jaw. Like that. And the first operation, cutting operation, will be to cut off these rather large overhangs, because I have a concern that when I face it off with a fly cutter and this material gets thinner, that the fly cutter won't cut actually, but crumble the material. So I cut them off first. Okay, with that done, switch to the fly cutter to face it off. Now we do a chamfer. And finally, again, engraving. And that's it for the bottom side. And now for the final setup to produce these two holes in the counterbores. Again, we keep as X and Y origin the left side of the fixture, and we indicate Z on this surface. First operation is drilling two holes. Next operation is to produce the counterbores. chamfer those counterbores. Finally, we engrave a little logo.
Okay, we're done with the CNC machining part of this project. It took 4 setups, 15 operations, 6 unique tools, 11 tool changes, and a total machining time of 32 minutes and 24 seconds. What is left is just to press in the 2 needle bearings, and we're done. So when pressing in the bearings, you just need to make sure that you put them in from the opposite direction. Here we go. I prepared this little thing to press it in. And that's the finished part. And this is the fixture mounted to my service plate to measure tool offsets for the TTS system. I'll just put it in here. Put in a tool, and with one hand you can tighten it, and to loosen it, put it in the other one, and then you can loosen it. Alright, so we're almost at the end. The only topic left to address is this rather embarrassing story about this little pocket marked in red on my vise. That was the very first cut I took with my Tormach. I forgot to measure the tool offset of my hammer in a compressed state when both dials read 0. I measured it at the idle state, and that led the machine to run right into my vise after I hit cycle start for the very first time. Very frustrating. I expressed my feelings at that point with a lot of words starting with F. But I decided to leave this dot in place. I marked it in red as a reminder that the concept of measure twice, cut once is also true on a CNC mill. And it seems to work, because ever since I have not done the same mistake again. Thank you very much for your attention, and I'm very much looking forward to see you soon.